All right, let's unpack this week's subject. We're doing a deep dive into the specs for a really specific piece of tech,
Yeah, very specific.
the NTI EBE1-P1000 rugged miniature piezo alarm. And our mission, really, is to figure out why anyone would need to engineer a simple beep with this much precision.
Well, when you see a spec sheet this detailed, you know right away you're not talking about a doorbell.
Right.
This is mission critical stuff for security, for environmental monitoring, places where an alert has to work. No excuses.
The purpose seems simple enough. It just makes a loud, continuous tone. But the way they get there is pretty complex. Let's start with the noise.
Okay.
We're looking at an output of 95 to 103 decibels at 2 feet. I mean, 103 BDB that's like a jackhammer, isn't it? It's impossible to ignore.
It is. And what's fascinating is the tiny amount of energy it needs to do that. The input voltage is specified as 5 to 15 VDC, a really wide range.
Hold on, 5 to 15 volts? That seems almost imprecise for a device like this. Doesn't that make it harder for the installer?
Actually, it's the opposite. That flexibility is a core feature.
I see.
It means you can hook it into almost any power source you find in a remote installation without needing some special, delicate regulator. It's about efficiency,
Yeah.
not elegance. This thing is meant for the wild.
Okay, so here's where the story gets really interesting for me. They call it miniature. It's only about an inch across.
Tiny.
But the ruggedness features, they tell a completely different story. What makes this little box such a beast?
It's all in the specs. I mean, first, it's epoxy-encapsulated and polarity-protected, so you can't really damage it by wiring it wrong or getting it wet.
Okay, that makes sense.
But the real badges of honor here are the compliance ratings.
And they give us two big ones.
Exactly. First, you've got IP68 protection.
Right.
That means it's totally dust tight and can be continuously submerged in water indefinitely.
Wow.
And then, crucially, there's the ASPM B117 rating. That's the standard test for salt spray and corrosion resistance.
So you're telling me you could pull this thing out of a freezer, hose it down with salt water, and then leave it on a rooftop in Arizona, and it would just keep working.
That's what it's designed for.
Yeah.
Brutal durability.
And I see the approvals, RoHS, UL, TAA compliant. That points to this being for, what, high reliability government or major infrastructure projects?
It does. And that level of environmental resistance, it raises a new problem, doesn't it? If this alarm can survive on the ocean floor, where's the equipment that's controlling it?
Usually very, very far away.
Very far away.
Which brings us perfectly to the biggest challenge, the one that's right there in the name, the P1000. That means the max cable length is 1,000 feet, over 300 meters. That is just a massive distance for a low-power device to maintain its signal.
And that's the whole engineering focus. The entire product line confirms it. You have the P800, the P600, the P400.
I see.
They're all basically the same device, just distinguished by how long of a cable they can support. The real investment here wasn't just making a tough little box that beeps. It was guaranteeing that beep could get to the end of a third of a kilometer of wire, reliably.
So when you put it all together, what this means for you, the listener, is that this alarm isn't just a component. It's really a statement about system design. It's a tiny, loud alert built to survive incredible punishment and operate across these huge demanding distances.
Exactly. And given that level of specific protection, IP68 for immersion, ASTM B117 for salt corrosion, it really forces you to think. It makes you wonder what kinds of remote, harsh, or maybe even underground environments are being protected right now that demand an alarm that can survive being submerged in salt water 1,000 feet from the thing that powers it.